Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Ascending Sums by Sudoku and Senikei. And here are the rules. We have normal Sudoku rules apply. That is, each row, column, and 3x3 region has to contain the digits from 1 to 9 once each. And we have a new rule set, which is ascending sums, where a clue outside the grid gives the sum of all continuously adjacent increasing digits up to and not including the first digit that decreases in that row or column from the direction of the clue. For example, the row, so let's do it here, 4, 5, 6, 1, 2, 3, 7, 8, 9 would have an ascending sum clue of 15 in this direction because it's 4 plus 5 plus 6, because then it decreases from the 6 to the 1. So therefore, that's not part of the sum here. And in one direction, and in the other direction, it would just be 9 going from the right because it immediately descends from the 9 to the 8. So the 9 would be the only ascending part of that sum. So the first point where it basically decreases in a row or column in the direction, it immediately stops counting those digits for sums. So that's why this would be 4 plus 5 plus 6, because these are all increasing, and then immediately it decreases to the 1, so then it stops summing things up. So then it's just the sum of 4, 5, and 6. And this immediately decreases from 9 to 8, so therefore this sum would be 9. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. We're going to mark... For sums going left and right, horizontally in other words, we're going to mark the ones that are counted as green and the ones that cannot be counted as blue. To add up to 5, we're definitely counting the first digit. Same with this. You can have 2 at most. That means none of these can be counted here. If we had a 5 here, to be continuously increasing to add up to 15, it would have to be 5, it can't be, it would be 5 and 9, which only adds up to 14, or 5, 6, 7, which adds up to, at minimum, 18. So there's no way you can have a 5 here. Therefore, this must be 1, 2, it has to be 1 or 2. Because if you have 3 there, 3 plus 2 adds up to 5, but 3 decreases to the 2. Same with 4. 4 decreases to the 1, which means the 1 is not included in the sum. So this must be 2 digits here, and this is guaranteed to be 3 or 4. And this must be added up to 15. We have to have at least 3 digits here. So let's, in columns, we'll mark it with red. Maybe we'll mark it with pink. This could be 7 here. To add up to 10, it's at least 2. To add up to 16, you could have 2. So this is at least 2 that way. 15's at least, it could be 2. So 15 could be 2, 17 could be 2, 15 could be 2. 9 could be a singular. 12 has to be at least 2. 10 has to be at least 2. 9 could be 1. 7 could be 1. Okay. Um... Hmm. So this could be 7 by itself. Okay, this cannot be 1 or... So to add up to 7, it's either going to be 1, 2, 4, which would eliminate all possibilities for this. So it can't be 1, 2, 4. Therefore, it could be either 1, 6, 2, 5, or 3, 4, but the 3, 4 would eliminate all possibilities for that cell there. And if this were 1 or 2, you would necessarily have to decrease from this cell to this cell, right? Because the 1, 2 pair in the box means this can't be 1 or 2, it's 3 or higher, which is decreasing to here, and that's never going to add up to 15. So this must be a singleton here. So these are not going to be part of any sums. This must be a 7. So this has to be less than 7 and greater than 1 or 2. So we have 2 through 6 here. It could be 2, 6, and 7 adding up to 15. In fact, actually, if we have something higher here that is part of the sum, that's not going to work. Because that would be 7 and 8 at minimum, which adds up to 15 already for those 2 digits, but then these 2 digits would not be part of the sum. So then this has to add up to 15 here, guaranteed. So this is never added up, which means this must be 2 and 6. So this is 2 and 3 adding up to 5. This must decrease from the 2 to the 3. So that makes this a 1, because we cannot be increasing here, but that would be part of the sum, which means this must be 5, and therefore it's decreasing from the 5 here. That can only be a 4 because of the 1, 2, 3 in the row. So this is 4, which means the remaining digits in the row have to be 6 through 9. Well, this must be increasing at least twice. Can we increase 3 times? That would be 6, 7, and 8 at minimum, which is 21, which is too big. So this must be 2 digits, which means this must be 7 and 9 adding up to 16. That eliminates 7 and 9 in the box, so this can't be 7 or 9. It's 6, 8 as a pair, which eliminates 6 and 8 in the rest of the row, so this can't be 6, 7, or 8. It's 9. Okay. So that's done. 2 and 3. This is done here, so that's red. Realistically, we don't even need to color these. It's just basically the first parts, right? This must decrease here. So this is blue here. And this must be decreasing there. I guess we could just make it all blue, right? Maybe. This must decrease from 7 to this digit, so it's 4 or 5. For 4 digits, it's 1, 2, 3, and 4. For 3 digits, it cannot be 1, 2, 7 anymore, so it's 1, 3, 6, 1, 4, 5, or 2, 3, 5. But none of those can have a 5 in it, so then, okay, so if it's 4 digits, it's 1, 2, 3, 4. For 3 digits, oh, the problem though with that, 1, 2, 3, 4 means that this digit is going to be greater than it, so it must sum up with that sum also. So this cannot be 1, 2, 3, 4. So this must be 3 or 2 digits here, adding up to 10. No 1, 2, 7, no 1, 3, no 1, 4, 5, no 2, 3, 5, because of 7 in the row and the 5 in the box. So it could be 1, 3, 6. And the remaining digits in box 2 have to be 1 through 5 because of the 6, 8 pair and the 7, 9 in the box. Okay, so that's helpful. Remaining digits in box 1 are 4, 5, 8, and 9. And 9 cannot be here because of 9 in the row, so 9 has to be here. Well, where is the 8 in row 3? It has to be one of these 3 digits. If 8 is here, that guarantees that these 2 digits must add up with the 8 to add up to 10, but that's not possible with 3 unique digits with an 8. So therefore, the 8 has to be part of the sum, which means this must be 8 and 2 to add up to 10, because this cannot be... I guess we marked this a little early, but basically this proves that this has to be smaller than that digit. So no more 2 here. It's 1, 3, 4, 5 as a quadruplet. In row 3, that leaves this as a 6. Remaining digits then in this box 3, we have 1, 3, and 7. That eliminates 1, 3, and 7 in the rest of the box or the row. So we have 2 here and 1 of 4, 5. This must be 4, 5, or 8 here. This cannot add up to 2 digits adding up to 15. If it is, has to be 6, 9, or 7, 8. And none of these can be, and again, the 6 and 7 has to be the first digit, which none of these can be because of 6 or 7 already in the column, which means this is at least 3 digits. This is at least 3 digits. Again, this cannot be 4 digits here. It can be either 2 digits and then 1, or 3 digits and then 1 there. So this is at least 3 digits, which means this must start off with a 4 at maximum, I should say. Because 4, 5, and 6 does add up to 15. But if you try to have something higher that starts with 5, 5, 6, and 7 adds up to 18, which is too big. So this must be 1, 3, or 4 here. This must be 1, 3, or 4 here. This is 2 digits. Cannot be 1, 2, 7. This is 2 digits at least, I should say. Cannot be 1, 2, 7. Because this would be 7 then, and then this, to add up to 15, it would be 7 and 8 at least, which is 15, plus 1, which is 16 then. So this doesn't work if this is 7. Cannot be 1, 3, 6 because of 3 in the column. Cannot be 1, 4, 5 because of the 4, 5 pair in the row, in the column also. And 1, 4, 5 would eliminate all possibilities for this cell. So all 3 sets are eliminated because the possibilities were 1, 2, 7, which doesn't work because, again, that would force this to be 7, 8. And that already adds up to something greater than 15 with those 3 digits. Cannot be 1, 3, 6 because of 3 in the column. No 1, 4, 5 because that would eliminate all possibilities for that cell. No 2, 3, 5 because of 3 in the column. So this is guaranteed to be 2 digits here. So it could be 1, 9. 1 here, 9 here, 2, 8, no 3, 7, or 4, 6. This digit must decrease from here to here. 9 is here, so this cannot be just 2 9s by itself. So this must be it can be 3 digits, maybe. That would, okay, so if it were 3 digits, that would require this to be 2, 3, 4. But then it would be increasing from the 4 to whatever digit is next. So that doesn't work. So this has to be 2 digits here and then decreasing here. And these add up to 9. So we have no 1 because of 1 in the column. It could be 2, 7, 3, 6, or 4, 5. This is less than this digit here. So it cannot be 7 here. It could be 6 here. And this digit must be greater than both of these digits. So this is 3 at least. So 3 through 6 there. Um, If we try to have this be 3, that's 3, 2, 1. The problem is that would force this to be 4, 6, and then this couldn't have a 2, 3, or 4 available. So this can't be 3 here. Can we have 4 there? No, because if we have 4 here, these digits would all be 4 or less. That's 3 digits there. And these would be 4 or less. That's 5 cells in the box requiring a digit from 4 or less. So this cannot be 4 here. Which means this digit is smaller than that. It cannot be a 5 then. This can't, because if this is 5, then this would be 6. And that's not smaller than that, which would mean that would add up to greater than 9. So this is 2 or 3 here with 6 or 7. This must be between these two digits. So we have up to 5 and down to 2. So 2, 3, 4, 5 is possible. No 3 here because of 3 in the column. So does this add up to 15 if this is larger? It could. This is smaller than 7. So this has to be 1 through 5. 1, 3, 4, 5 there. Only 1 out of 8 or 9. Well, okay, both of 8 or 9 could be here. Okay, what happens if both of 8 and 9 are here? That means this is 6, so this would be 6 and 4. This would have to be less, that would mean this is not 6, that's 7 and 2. This is less than 6, it would have to be 5, and this couldn't be 5 or 6, so that would be broken. So, we cannot have both 8 and 9s be here. One of the 8 and 9s has to be here, the other one has to be here. Which means this is not 4, it's 8 or 9 here. We have an 8 or 9 here. One of the 8 or 9 is here. We don't know which. Well, where is 7 now? In box 7. Can't be here. Can't be here because of the way that works. And because this has to sum up to 15 increasing. So 7 can't be here. It would be 7 and 8. That would be too large for 16. 7 can't be here because of 3 is 7 in the column. So then 7 has to be here. So this is 7, which just makes that 2. This can't be 2. This is 1 and 9. That leaves 8 remaining in the box. 1 eliminates 1 here. 2 eliminates 2 here. 8 has to be one of these, which means this can't be 8. It's 9. And can we have this be 3, 4, and 5? Can this be 5 ever? If this is 3, 4, 5, that only adds up to 12. If this is 5. So 5 forces this to be 4, which makes that 3. That only adds up to 12, but we can't add 3 to add up to 15 because it would be decreasing. So therefore, this cannot be 5. It's 6. And then to add up to 6, we have 6 and 7, but that's already 13. If we do that, so then it must be decreasing here, and then this must be 4, 5, and 6. So we have 4, 5, 6 here. This can't be 4 because of 4 in the column. We have a 3, 8 pair remaining in box 7, which eliminates 3 and 8 in the rest of the box. This can't be 3, it's 1. This can't be 1, 3, or 4, it's 5. 5 eliminates 5 here, so it's 4, which eliminates 4 in the rest of the box. 4 eliminates 4 here, so this is 1, 3, 5 as a triplet, which eliminates 1, 3, 5 in the rest of the box, so that's 2, 4 as a pair. 5 eliminates 5 here, so that's 8, which makes this 5. To add up to 15, It could be 1, 6, and 8. That is possible. Okay, remaining digits in column 2. We have 2, 6, and 7 left. In column 3, we have what? 4, 6, and 8? No, 4, 3, 4, and 8. So it cannot have 1, 7 here, because 1, 7 in increasing to 8 at minimum adds up to 16, which is too large. So it's either 1, 6, 8 here, or it could be 1, 2 with something else, 3 or 4 there. Hmm. Um, hmm. Okay, this at minimum. Okay, so can this be 3 digit? This can no longer be 4 digits adding up to 12 because we have 1 and 2 already in the row. Can we have 3 digits adding up to 12? It would have to be 3, 4, 5, but then this digit would be greater than the 3, 4, 5, which would mean that therefore we'd be the sum of 4 digits, which already adds up to greater than 12. So cannot be 3 digits here. It must be 2 digits, which means this must decrease here. So this is either 3 and 9, 4 and 8, or 5. Cannot be 5 and 7 because of 5 in the column. Can't be 4, 8 because of 4, 8 in this column. So this must be 3 and 9, which means this can't be 3. That's 8, which makes that 3. That's 3 in the corner. We celebrate because we're close to solving this. This digit, can it be 2 digits can it be 3 digits adding up to 7? Well, we can't have 1 here, so no, because we can't be 1, 2, 4. Can it be 2 digits here? No, because it can't have 1, 6, or 2, 5, or 3, 4 here. So this must be 7, and this must decrease here. So this is a 7. Remaining digits in row 9 are 4, 5, and 6. No 6 here because of 6 in the column. So we are guaranteed one of these two is a 6. This digit must be smaller than the 7. It could be 1, 2, no 3 because of 3 in the row, 4, 5, or 6. And 6 can't be here because of 6 has to be one of these two digits here. This is less than 6 also. Cannot be 4 or 5, so this is 1, 2, or 3. This is definitely smaller. Forgot about that. So this is done. This is done. 2, 3 increasing, then down to 1 decreasing. 5 decreasing to 4. 7 decreasing to 4 here. 2, 8 increasing, decreasing to 6. 7, 9 decreasing to 1, 3, or 5. 2, 6, 7 decreasing to 5 here. That's not done. This is not done. That's not done. This is done. 3, 9 decreasing to 4, 5. 7 decreasing to 1, 2, 4, 5. 2, 7 decreasing to 6. 1, 9 decreasing to 5. 4, 5, 6 decreasing to 1, 2, or 3. Where is 9 in box 8? Cannot be here because of 9 in the column. Can't be here because of 9 in the row. Can't be here because of 9 in the row. Can't be here because this must be decreasing. So 9 has to be here. Okay. This can no longer be 2 digits adding up to 17, because if it were, it would have to be 8 and then 9. And 9 can't be here because of 9 in the column. So it must be at least 3 digits here. 9 cannot be here because of 9 in the row, so therefore this must be at least 2 digits adding up to 9 here. So where is the 9 in column 9 then? This is never going to be increasing from a 9 to whatever digit here. Same with this, so 9 has to be there. That gives us 8 and 9s. We know where the last 9 has to be. It's there. So this, if we try to have 1, 6, and 8, it's always going to increase to the 9 there. So therefore, this must be part of the sum, and then it must decrease from there. So this cannot be 6, it's 2. That eliminates 2 here. And then we have 1, 2, and 9 add up to 12, plus 3 adds up to 15. That eliminates 3 in the rest of the column. So this must be increasing for these 3 digits to add up to 17. And we no longer can have 4 available because the minimum of 4, 5, 6, 7 is too big. 4, 5, 6, 7 adds up to 22. So therefore it must be 3 digits, and therefore it must be 4, 5, and 7. No, 4... It can't be 5. 5, 6, and 7 adds up to 18, which is too large. So we definitely have a 4 here. 4, 5, and 8 works. So the remaining 2 digits must add up to 13, because 17 minus 4 is 13, so we get a 5, 8, or 6, 7. Where is 7 in row 5? Can't be here, they're filled out. Can't be here because of 7's in the columns. So 7 has to be here, which makes this 7 and 6. This must decrease from this cell to this cell. So therefore cannot be 8. It's 5, which makes that 8 there. 5 eliminates 5 in the rest of the column. 7 eliminates 7 here. Where is 6 in column 9? Can't be here because of 6 in the boxes. Can't be here because of 6 in the row. So 6 has to be there. To add up to 9 here. No 1, 2, 6. So for 3 digits, it could be 1, 2... It can't be 1, 2, 6 because of 6 in the box. It could be 1, 3, 5. That is potentially possible. 3 eliminates 3 here. So it could be 1, 3, and 5. It can not be 2, 3, 4 because of 4 in the box. For 2 digits, it can't be 1 and 8 because of 8 in the column here. It can't be 2 and 7. Can't be 3, 6 because of 3 in the column. Can't be 4, 5 because of 4 in the column. So this has to be 1, 3, and 5 adding up to 9, which means it must decrease here. So we have 1 here, 3 here, and 5 here. That forces this to be less than 5. It's 2 or 4. We have a 1, 2, 4 triplet in column 6, which eliminates 1, 2, 4 in the rest of the column. So no 1 here. It's 3. That eliminates 3 in the rest of the box. That leaves this as a 6, 8 possibility. Remaining digits of box 6 have to be 2 and 8. This can't be 8 because of 8 in the column, so that's 2, which makes this 8. This 8 eliminates 8 here, so it's 6, which makes this 8 and 6. 8 eliminates 8 here, so it's 4. 6 eliminates 6 here, so it's 7. 7 eliminates 7 here, so it's 6. 4 eliminates 4 here, so it's 8. Okay, remaining digits in row 4 are 1 and 3. So these are all done. We have 2, again, 2, 3 increasing down to 1, so that's just 2 and 3. 5 decreasing to 4, so it's just 5. 7 decreasing to 4, it's just 7. 2 and 8 add up to 10. 8 decreases to 6, so that eliminates that. 1, 2, 3, 9 is 15, decreases to 8. 4, 6, 7 is 17, decreasing to 5. 1, 3, 5, 9, decreasing to 2 or 4. 7, 9, decreasing to 1 or 5. 4, 5, 6, decreasing to 1, 2, or 3. That's 15. 3 and 9, decreasing. So 3 and 9 adds up to 12 and decreases to 4, 5. 7, decreasing to 1, 2, 4. 1 and 9 decreasing to 5, 2 and 7 decreasing to 6. That's 9 and 10 there. Remaining digits in row 6 are 2, 4, and 7. This can't be 7 because of 7 in the column, so 7 then has to be here. We have... The rest has to be normal Sudoku because we're done with limiting things now. 1 eliminates 1 here, so this is 7, which means this can't be 7 here. It cannot be 3 because of 3 in the column, so that's 1, which makes that 3. 5 eliminates 5 here, so it's 4, which eliminates 4 in the rest of the row. So this becomes a 5-6 pair. Remaining digit in column 9 is an 8. Remaining digits in column 8 are 5 and 7. This can't be 5 because of 5 in the row, so that's 7, which makes that 5. Remaining digits in column 7 are 1 and 2. So that doesn't have very many restrictions. Remaining digits in row 7 are 1, 2, and 3. Remaining digits in row 8 are 1, 2, 4, and 8. But 8 cannot be here because of 8 in the column, so 8 has to be here. That makes this 1, 2, or 4. We have a 1, 2, 3, 4 quadruplet in column 5, which eliminates 1, 2, 3, 4 in the rest of the column. Also, 6 eliminates 6 here, so this is 5, which makes that 6. 5 eliminates 5 here, so that's 1, which makes this 5. 1 eliminates 1 here, so it's 3 and 1. 3 and 1 eliminate 1 and 3 here, so it's 2. 2 eliminates 2 here, so it's 4 and 2. 2 eliminates 2 here, so it's 1 and 2. 2 eliminates 2 here, so it's 4 and 2. So this 2, 4 eliminates 2 and 4 here, it's 1. No 1 or 2 here, it's 4, which makes this a 3. And that's how you solve it. Yeah, fairly straightforward. I was curious about how the ascending sums would work, and it is actually pretty restrictive. Particularly for the first digit, right? Because there's only so many digits you can have there. Right? It's interesting though. I don't think necessarily you're going to have. You could use it for multiple types of puzzles, I feel. I don't think it's overly restrictive. So we could potentially see some more ascending sums puzzles in the future. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.